Hello everyone, welcome to the 8th video of Figma plugin development. In this video, we're going to work on the Figma plugin idea that we had shortlisted in the previous video. Now this is a complete hands-on video with a step-by-step guide to help you build a plugin from scratch. I would request you to follow along with me in all the steps which are covered in this video so that you have a fully functional plugin ready with you by the end of the video. Now, post this video, we are going to have another video which is going to be a continuation of this topic, covering all the edge cases of the plugin that we are building in this video, so that we can avoid all those runtime errors which could be caused otherwise by any of the expected or unexpected user input. So let's go ahead and start building the plugin. All right. So as you remember in the previous video, I had listed down some of the actions that I do on a frequent basis, and all these are some monotonous action that can be otherwise converted into a plugin. And we went ahead with exploring this idea in particular. And we had listed down all the steps that might be required to execute this idea into a plugin. And we had also explored the APIs which are supported to perform these actions. So now let's go ahead and write a plugin to do that same. So what I have done over here is I have added a dummy screen for us to visually understand what is the expected outcome that we want this plugin to do. So ideally what it should do is it should take the selected screen which I have over here, and it should duplicate that screen. Once that screen is duplicated, all these elements over here, they should turn into rectangles or ellipses, and they should all have linear gradient so that it looks like they're all in a loading state, so that it looks like a skeleton of a particular page. So let's go ahead and for now delete all these elements, and what we can do is we can also give this a white background. And to demonstrate what we want as an expected outcome is I will try and replicate some of the elements which are already present on this page. So let's say I want this particular group to be converted into a rectangle like this. It can have a 40 cross 40 height and width, and let's say it can also have some roundedness, and I want this to be again converted into a rectangle. And I can just keep doing that, and as you can see, it's a very tedious task to do this particular thing, and that's the reason why we want Figma plugin to do that. So let's go ahead and apply the corner radius to this one, and once you keep doing that, you will have this. And yes, this is what we expect this plugin to do. So now let's go ahead and tally these steps with the original steps that we had initially written. So I'm going to paste them over here. So as you can see, we have duplicated the screen. We have filled the linear gradient into the shapes or text elements, whichever was present there, and we have positioned them correctly. So now what we have got to do is we need to convert this manual steps into a plugin which can do this for us automatically. So let's go ahead and create a new plugin for this. So as you remember, what we can do is we can head over to our profile over here and click on plugins, and then we can click on create new plugin for us. And once we do that, as you can see, it asks me for the name of the plugin. Let's give it a name, let's say Skelify for now, and we can click on continue. And here we can select what kind of template that we want. So for now, I don't want a UI for this plugin. I want it to directly run once I trigger the plugin. So I am going to go ahead with the run once as template, and I can click on save as. Once I do, it asks me for the location where I want to save it, and I can select the location where I want to, and then I click on save, and that's how I can successfully create my plugin. Now what I need to do is I need to go ahead and open this as a project in my VS Code. So let's go ahead and do that. We'll click on open, and we can locate this plugin where we have created it. And yes, now we are inside our project. Now let's go ahead and do the very first thing. We can open our readme.md file, and from here we can see the command for installing the typings file that we need. Now this is a primary command that you should run for any of the plugin that you work with. So let's go ahead and open our terminal with the shortcut key Ctrl plus tilde, and once we do that, we can see this terminal window opening over here. We can paste the command over here and run it, And as you can see, it will try to install the typings file over here, and the file is installed. Now once that's successfully done, you can close the terminal and the readme.md file. Now you have your code.ts file. Now again, as you can see, the code.js file is still empty. You can just take this code.ts file and convert it. You can click on terminal and click on run build task, and over here you can select on watch tsconfig.json. Now what we'll do is this will start your compilation and it will convert your TS file into a JavaScript file, as you can see over here. Now we can start writing the logic for our plugin, which will convert any screen into a skeleton loading state. So the first thing that we need to do is we can actually go ahead and delete all this template code. If you remember the code which helps us create rectangles, we don't need this anymore. But we'll still have this Figma.close plugin, as we need it to close the plugin once we are done doing what we want to. So as you remember from our previous videos, any plugin is divided into two categories. Either it can manipulate the existing content, or either it can insert new elements in the artboard. But if you remember, what we want to do is we want to create a shimmer or a skeleton screen of the existing screen. So that means that we want to manipulate the existing content, and to do that we first of all need the selection of what user has selected. So let's go ahead and write a code for that. What we need to do is we can create a for loop. Again, the reason why we're creating a for loop is because a user can select multiple nodes and we cannot always expect them to only select one node. So what we can do is we can write a for loop, and we can write constant node of figma dot current page dot selection, and this will help us get to the selection of what users have selected. And now what we need to do is, as you remember, the first step over here is to duplicate the screen, to duplicate this particular screen and place it right in front of the previous base screen. So what we can do is we can actually go ahead and create a variable for this. We can call it, let's say, duplicate frame, and to this duplicate frame variable we are going to write a function to create a new frame, and we can actually write it like this, and this will help us create a new frame. Now what we need to do is we need to position it accordingly. So if you remember, we need to position it right next to the base frame which we have. So what we're going to do is we're going to set its x-axis, and we're going to give it a value of node.x, that is our selected layer, plus node.width, that is the width of that particular layer, plus the extra padding that we want. So, and that in our case could be, let's say, 200 pixels. Now we have given it a position, and now what we can also do is we can also give it a y-axis position, and this can be same as the selected node. Now what we can do is, now that we have duplicated and placed it right in front of the base node, we can also resize this newly created frame to match it with the existing selected frame which we have over here. So what we can do is we can write a function over here which we have also used in our previous videos, which is frame.resize, and to this we can give the width and height that we want to. So again, we want it to give the width of the selected node and the height of the selected node. Now once we do that, it will assign those width and height to this newly duplicated node. And that is how we can duplicate the selected node and create a new node right in front of the previous base node. So let's just go ahead and save it and see if it's doing as expected or not. What we can do is we can head over to our Figma, and let's actually put it somewhere right over here. We can select this existing node, and we can right click and go to plugins, and over here from the development section we can click our plugin, which is Skelify, and as you can see, it creates a new frame for us which is exactly the same as the previous height and width, and it's placed 200 pixels towards the right of the selected frame. And so far our code is working as expected. So now that we have duplicated our frame, let's just go and add some comments in this code so that we have the idea of what exactly is happening, because this can get a little complex while you're writing it. So this is where we are getting the user selection. So I'm going to write that. And after that, what we are doing is we are creating, let's say we are duplicating the selected frame, or to be precise, we can duplicate the selected node. And then I think these are very much self-explanatory, where we are changing the position and resizing the selected frame. So we can write it, changing the position, and here resizing the duplicated frame. So this will be helpful for us when we are revisiting this code, or we are even making some changes on this code. So now let's go ahead and see what needs to be done next. So now that we have a duplicated node in front of us, we also need to get the inner elements of this particular screen. We need to get all these individual values, and we need to convert these individual values into rectangles, or let's say ellipses, and then apply linear gradients on top of them. So to get to these values, what we need to do is we need to first of all traverse through all the elements available in this frame. So we need to travel through all the child elements of this particular frame. So what we're going to do is we're going to again write a new loop which will help us do that. So let's go ahead and write that up. Now what we're going to do is we're going to write a for loop which will again traverse through the child elements of this particular selected node, and let's go ahead and write that down. But as you can see, there's a warning which is coming over here that this children property does not exist on scene node and slice node. So let's go ahead and write a validation over here where we will only go inside this particular node only when if it's a group or a frame. So what we can do is we can write a node dot, let's say type, and we are checking over here that equals to equals to equals to, and it can be, let's say, frame, or it can be node dot type equals to equals to equals to group. So once we do that, you will see that we are no more getting this underline over here, and we can put this under a curly bracket. So now what we can do is we can write what should happen when we are running this for loop. So in this for loop, when we are traversing through the child elements of this particularly selected node, the first thing that we want to do is we want to create a rectangle for every selected child element. Now how we can do that is we can create a variable, and we can call it scalement for now. And with this scalement variable, what we want to do is it should first of all create a new rectangle. So what we can do is scalement is equal to figma dot create rectangle. Now what we need to do is we can give it the position and the size of that particular selected child. Now how we can do that is we can write scalement dot resize, and over here we can give child dot width and child dot height. Now this is how we will be getting the height and width of that particular child element. Now we can also give it the position of that particular child from that base node. Now to do that, what we can do is we can do scalement dot x equals to child dot x, and scalement dot y equals to child dot y. Now this will help us get to the position of x and y axis of that particular child element, and we have also resized it. So now that we have got the size and position in structure, let's also give it some visual enhancement to get to that linear gradient and the corner radius the way we want to. So let's go ahead and apply a corner radius to this particular element. We can do it by writing scalement dot corner radius, and let's give it a property of 6 pixels. And now that we have given the corner radius, we can also give it a linear gradient the way we want to. So if you remember, we had initially went to Figma docs and figured out how is linear gradient handled. But now when we go back to that, we can see that in the fill element, we need to provide a property of type, which can be gradient linear. And in that, we need to provide two values, which is gradient transform and gradient stops. So let's go ahead and write that up. We can write it by like this: scalement dot fills equals to, and over here we can write these three values: type, gradient transform, and gradient stops. So let's write the type as we know is going to be gradient linear. So we can just copy and paste it right here, and we also need to write gradient transform and gradient stops. Now you might be wondering, how do we get the value of gradient transform and gradient stops? So if when we read over here, gradient transform is nothing but the position of the gradient within the layer, and gradient stops is the array of colors and their position within the gradient. Now if you see, the way we handle gradients inside Figma application is we just create the element and we just simply insert it like a fill, let's say over here, and I can give a gradient normally like this. But this is not the way how it's handled with the Figma plugins. They maintain a array of all these colors and the position and the angles the way we give it, and in terms of arrays. So to give these arrays, we cannot sit and calculate them by our own. So I have figured out a way where we can actually create the rectangle and apply a gradient in the Figma application itself, and then convert that particular gradient into the gradient stops and gradient transform values the way we need it. So what I'm going to do is I'm going to, let's say, take this rectangle, the gradient is already applied, and I'm going to just copy the style of this, and I'm going to apply it and paste it over here. Let me paste it like this. Now we have a rectangle which has the gradient the way we want to, right? Now what we need to do is we need to get the gradient transform and gradient stops value of this particular rectangle, so that we can paste those values inside our VS Code, so that when we are creating a new duplicate element, we get this particular gradient. Now to get this gradient, what we need to do is we can actually use this particular project only. We can actually comment down this code, and we will be still needing the constant node selection because we are going to get the gradient stops and gradient transform value from this particular rectangle. So let's just go ahead and write a code for that. And it's just a simple one line code. What I'm going to do is I'm going to write console.log, and over here I'm going to print the value of node dot fills. So this will help us get to the gradient stops and gradient transform values. But we need to write a validation over here because it's not supported for all the type of nodes. What we can do is we can write if fills in node, and in that case it should run this particular code of line. We can just save this and then go ahead and run our plugin and get that gradient transform and gradient stops value. So I'm going to run this now. Let's say Skelify. As you can see, nothing is happening over here because it's trying to print that gradient transform values on my console. I'm going to open the console, and as you can see over here, it is printing array1, and inside this array is this 0th node. Because we only have one node selected, that's why we only have one array over here, which is 0. And inside this array we have all the values printed for that fills. Now fills is having gradient stops and gradient transform. Now these are the two values that we are going to copy as it is and paste it over here in our VS Code. Now that's how we will be able to apply this particular linear gradient to all the elements that we are duplicating and creating. So let's just go ahead and copy these values and paste them in our particular code. So what we can do is we can just comment this down, and we don't need it anymore, and we can uncomment our previous code. So as you can see, we have gradient transform and gradient stops, and we need to provide values for this. So now we can go ahead and write the values for gradient transform by referring to our console.log over here. And as you can see, this gradient transform, we have two arrays. There is the 0th element and the first element. So now let's refer to the 0th element, and inside this 0th element also we have three values. So what I'm going to do is I'm going to write another bracket over here, which will help us create the array, the first 0th array which we want. And I'm going to paste all these values one by one over here. And now I'm going to create the first array, and I'm going to paste its value one by one. Okay, so now we have got our gradient transform value from this particular rectangle. Now let's do the same for gradient stops as well. Now I can go and close this, and I can go inside my gradient stops. Now as you can see, again in my gradient stops I have 0, 1 and 2. That means I need to have 3 elements in this array, and inside 0 also I have 2 elements, which is color and position. So let's go ahead and create our first array with these 2 elements. Now as you can see, the value of the position over here is 0, so I'm going to give it. And now let's define the value for this color element. Now in my color element, I have four elements inside this array, which is R, G, B, and A. So now we have got our first element in this particular color. Now let's do the same for the second one as well. Now, as you remember, we have got let's say three array elements in this array. So now let's do for the second one. Now that we have got the color and position for the first one, so I'm just going to add a comma over here and create another one. And once you do that, you will have the value for your gradient stops and gradient transform. So now we have defined some visual properties like corner radius and fills for this particular rectangle child element that we are duplicating. So now let's do one last thing before we go and run this plugin. We need to append this particular child element to our newly duplicated parent node frame. So what we can do is, as you remember, the name of this frame is duplicate frame. We can write duplicate frame dot append child, and in this we can give the name of this particular child, which is element, and this will insert this element into this particular frame. Now let's go ahead and save this and run our plugin. I'm going to just delete this rectangle because we don't need it anymore. Let's go and let's take this base node. We're going to run our plugin. Now, as you can see, when I run this plugin, I get rectangle duplicates with the linear gradient applied. But there is an issue happening over here. It's saying that it is not able to resize the elements which is having the heights below 0.01. So we need to add a condition to check if the height of the element is more than 0.01, and then only make the duplicates. So as you can see, I have separated lines over here which is causing that issue. So let me go and write a validation for that, and we will be able to overcome this error. We can simply do that by writing if child dot height is greater than 0.01, and then we can copy and put our code in this particular if condition. And let me just close this, and yes, now we shouldn't be facing this error anymore. Let me just delete this and rerun the plugin by option command and P. And now we have our duplicated screen, which is exact duplicate of all the elements which are present in this base node. And as you can see, all these elements are converted into rectangles with the linear gradients applied to it, giving us a complete effect of a loading state. Now that is a really good plugin that we have built. But wait, there are few things which I couldn't help but notice, that some of these elements are not exactly as they should appear. So as you can see, I'm not able to find this as an individual element and this one as an individual element. And even when I look at this group, I cannot find the text over here. Now what I can notice is that all these elements are inside a frame or a group. So what exactly is happening is that our plugin is traversing through each and every element, and it's only going through the sibling elements. By that, what I mean is that whenever it comes across a group of frame or child elements, it is directly replicating them into a rectangle. It's not going inside those elements and replicating the individual elements present there. So what we need to do is, we need to teach our plugin to check if a selected node is a frame or a group or an instance. If it is any of that type of node, then we need to program it to go inside that particular child element instead of duplicating it directly into a rectangle. By that, we will be able to go to the leaf level node, and we will be able to reach to the last child element instead of directly duplicating the group that we have over here. So now let's go ahead and modify our existing plugin to make it go till the child level element. So what we're going to do is, we're going to write a condition over here where we're going to check if the selected node type is frame or group or instance. And in case if it's not frame or group or instance, then we are going to run this particular line of code. But otherwise, if it is a group, frame, or instance, in that case, we're going to traverse inside that child element so that we can traverse through the elements of that group or frame or instance. So let's write a condition to do that. Now what we can do is, we can write over here that if child dot type is not equal to frame, And if child dot type is not equal to let's say group, and if child dot type is not equal to instance. So in case our child is not frame, group and instance, then we want it to, directly duplicate that particular child element and replicate this as a rectangle, and we can put our code in this particular bracket. Now we have got the first case covered, if the child is not a frame, group or instance. But otherwise, if child is frame or a group or instance, then we should tell our program to actually go inside that particular child element. So now what we can do is we can actually write another for loop and traverse inside that particular element. But wait, we cannot keep writing this for loop every time we come across a group or a frame. That will be a very long program, and that's very non-efficient way to write a program. So let's go ahead and write a recursive function which will do this for us. So this function will keep calling itself in case it comes across a frame, a group or an instance. So if you don't know much about recurring functions, I will add a link to that in the description below. You can go and read that. There's a really nice article about it where you can learn and understand what exactly are recursive functions. But just to give you a basic understanding, a recursive function is a function which calls itself until and unless a condition becomes true. So this helps us avoid the repeated for loops or while loops or any other loops, and it makes the program more efficient. So let's go ahead and write that down. What we can do is we can actually convert this whole group of code into a function. So let's say starting from the node children over here, we can create a function and call it scalyfy, and what we want as an input in this function could be node element that is selected by the user. We can actually delete this condition as it won't be of any use. Now we can delete this, and we can delete the extra bracket over here as well. So now we have this function, and this takes in node as a parameter, and we can actually copy this whole code over here. Let me just collapse this, and yeah, this is how our function will work. We have a function in which we will run this for loop and we will traverse to the node children, and we will check if the height of that node children is more than 0.1, and we will also check if that particular child is not frame, not group and not instance. And now what should happen in case if it is any of them, we should make this function call itself so that we can again traverse inside this node children, and it can keep going inside and inside until and unless the node type is not frame, not group or not instance. So let's go ahead and write that down. So in this case we have the if condition taken care of. What we can do is we can actually collapse this and we can write a else condition. So what we can do in this else condition is we can write our function scalyfy, and we can recursively call it by passing a node, which could be a child element in our case, because we are going to go inside this particularly selected child element. And once it goes inside this, it's going to again run this, and it's going to check if it's a frame, group or instance. If it's not frame, group or instance, it's going to run this. But otherwise, if it is, then it's going to again go inside one level down, and it's going to again pass this new child element, and it's going to rerun the whole program. And this is how we'll be recursively traversing inside every group and frame until and unless we don't reach the leaf level node. So now that we have our function defined over here, we need to call this function to make it work. Now to call it outside, what we can do is we can actually come outside this function first of all, and over here we can actually call this function by passing this node selection over here which we have. So do remember, we are still inside this for loop, we are not outside the for loop, and inside this we are going to pass the selected node which is selected by the user. So let's go ahead and save this, and this should run and it should recursively traverse through all the elements which are group, frame and node. So let's save this and let's go back to our Figma, and let's just delete this, and we are going to rerun our plugin. Let me just right click plugin, and I'm going to rerun by clicking on Scalyfy. And as you can see, there is another error that we have come across. And in this case, it's the value of the width, which is less than 0.01. So as you can see, the value is of the width over here is lesser, and it's specifying me that the value should be greater than or equal to 0.01. So we can again go ahead and write a condition over here, which will help us avoid this case. And now this should work. We can delete this for now and we can rerun the plugin and see what happens. Okay, here we have got a duplicated screen, but now there's a different problem that we are facing. As you can see, some of these elements which should have otherwise come over here are, just aligning to the top left section over here. But why? Why are they not at the position that they were supposed to be? Now this is happening because we are traversing inside the frames and groups, and these elements, which are the child elements of these frames and groups, have their position relative to their parents. For example, if I select this one, you can see the position over of this frame is 24 x-axis and 736 y-axis. But if I select an image inside this, you can see the position of it is 0x and 0y, and this one is 10x and 57y. But whereas, as if I can see the absolute position, it's a completely different value. Now when we are actually assigning the values to this duplicated elements, we are giving the value using this variable over here, which is scalelement.x equal to child.x, scalelement.y equals to child.y. Now this x and y in this case is getting the value from here, which is 0 cross 0 and 10 and 57. So we don't want to do that. We are getting the relative value, and we don't want the relative value in this case, because getting the relative value is causing a issue for us. It's just aligning the elements on the top section, because it's calculating from this and it's putting it at 0 over here. We want it to come over here, and to make it come over here, we need to get the absolute value of this particular element. By that, what I mean is, instead of getting 0 and 0 over here because of its parent, we should consider the outer main node as a parent and get the value from that main parent. So in this case, it is 24 from the left side and 736 from the top side. So its y-axis is 736 and the y-x-axis is 24. To get this absolute value, what we have to do is we have to check the Figma documentation if there is support to get a direct absolute value instead of getting a relative default value. What we can do is we can actually head over to Figma docs and we can search for absolute transform. And over here, as you can see, in the absolute transform, there's an option, the position of a node relative to its containing page. Yes, exactly, this is what we're looking for. And once we go inside this, you can see that it's a transform matrix. By that, what they mean is it's a 3 by 3 matrix value, and it's not exactly a x-axis or y-axis single value. So we will be getting a matrix when we apply a absolute transform property, and we need to convert this matrix array into a x-axis or a y-axis. Now as you can see, the x-axis and the y-axis is the last element of each of these array. So in this first array also, the last element is the x-axis, and in the second array also, the last element is the y-axis. So we need to get the absolute transform value and take its last value of both the array positions and take that and convert it into the x and y axis that we want. So let's go ahead and write that property in our code. So what we can do is, instead of getting the child.x value, we can actually write child.absolute transform. And as you can see over here is the x-axis is the last element of the first array. So what we can do is we can actually write 0, and the last element is 0, 1 and 2. So we can write 2 over here. And the same applies for the y-axis as well, absolute transform. And in this case also, the instead of the first array, we need to take the second array. So instead of 0, we can write 1 over here, and here also we need the last element, which is 2. So now we're getting the absolute transform value, and we can actually just save this and we can see the results. Let's just save and run our Figma plugin. I'm just going to delete this one and see what happens. Okay, I am not getting any value at all. Now you must be wondering, Manik, have you gone crazy? Now let me tell you why exactly this is happening. This is happening because my selected node is on a different x and y axis. It's not starting at zero. Because it's not starting from zero, it's going to position my duplicated rectangles starting from zero, and that's why it's not appearing in this rectangle over here. So to test this out, we can actually place this on 0th x-axis and y-axis, and we can actually go there and again rerun our plugin and see if we get our rectangles on the absolute values as expected. Or so I'm just going to press option command and p, and yes, as you can see, we have all the child elements using that recursive function we just wrote, and all these are correctly placed the way we wanted it because we are applying absolute transform property. But wait, we cannot always ask the user to place their frames on 0th x and 0th y axis, right? We need to write logic to automatically get the 0th value and subtract it from it, so that no matter where the frame is placed, we are able to position all our child elements in an absolute way without even asking the user to change the position. So there's a hack for that as well. What we are going to do is, first of all, let's just undo and take this back to our old position where we had. And yeah, so what we're going to do is we're going to go back to our VS Code, and here we're going to first of all capture the value of the parent node that is there. So this, in this case, the parent node for us is captured when we are running the for loop for the first time. So we can actually go and create a variable and call it parent node, and to this variable we can actually give the value of this node. The reason why I'm saving this as a parent node is because this node value is going to keep changing, so I'm just going to capture the first node which is there. Now once I've got the parent node, I'm going to use this parent node as a reference when I subtract my values to get the exact absolute transform property. So what I'm going to do is I'm going to write minus parent node dot absolute transform, and I'm going to write 0 and 2. And in this case also, I'm going to write minus parent node dot absolute transform. And in this case, it will be 1 and 2. So let's go ahead and save this and see if our plugin is running as expected or not. So I've saved my program, and I'm just, as you can see, my x-axis here is 1559 and y-axis is 6030. It is not 0 and 0. So I'm just going to run option command P and see if the plugin is running as per our logic or not. Now when I run this plugin, as you can see, all the rectangles are exactly placed the way we wanted it. And we don't have to put our base node on 0x and y axis. That is because we are directly subtracting the parent position from the absolute child position. Now this is a slightly advanced logic that we have applied over here. So you can take some time and calculate the absolute position that are helping us over here. And believe me, you're going to find it super easy when you understand this logic. And that's how you ideate and write your very first Figma plugin from scratch. Now, there are still some edge cases that we can take care of. For example, there are some of these images which are in ellipse, but they are converted into a rectangle, like this one as well. So we can write an edge case to detect if a selected node is a rectangle or ellipse. And if it's an ellipse, we will duplicate and create an ellipse instead of create a rectangle. And one more edge case could be, let's say there is this button and there is this back button. So these are some of these last child elements, and we don't want to go inside and create a shimmer. We want the parent elements to be the last element for us to traverse. So we can write some of the edge cases and make it flexible for the users to make this plugin meet to their requirements. And all of this will be covered in our next video. But for now, congratulate yourself because you have ideated and written a plugin from scratch, and that definitely deserves a pat on your back. So see you in my next video where we're going to write some of the edge cases for this particular plugin. And that was it for this video.